In question 3, we're given information about not A, probability of B given A, and the probability of B. Now, reading ahead, it makes sense to have a note here. The probability of A must be 0.4. Now, you're told, in this instance, you've got to be able to find the probability of A given B. Now, I'm going to work, firstly, with the probability of B given A, and that will equal the probability of A and B occurring, given the probability of A has occurred. Now, that's 0.3. I don't know what the probability of A intersect B is. Probability A is 0.4. So therefore, probability of A and B occurring, which is 0.12. I now have enough fuel to be able to go ahead and find the probability of A given B. Note, the probability of A and B is the same as the probability of B and A. And 6/25 as my answer. In B, you're asked to work out the probability of 3 girls selecting a green ribbon. Now you think about it, you've initially got 12 ribbons, and then you've got 11, and then you've got 10 by the time the third girl comes around. So probability of green, green and green, is going to be 8/12, or 2/3, times 7/11, and then times 6/10. Now, fortunately, your calculator can do this for you pretty well. Keeping it in standard notation gives me 14/55. Now, if I wanted to, it does take a bit more caution, I could have done all this in one hit on my calculator. Just make sure you group everything together. And once again, 6/10 would be useful. I get 14/55. Please get used to using your calculator for these calculations. Unless it's clearly out of 100 or we're going to get a decimal figure, you'll find that many of our answers require us to work in fractions and not decimals.